The reformer process produces a hydrogen-rich gas with a purity that varies between 70 and 90% in volume. This gas will naturally be used to hydrotreat the refinery feedstocks, both for hydrotreating gasoline and diesel fuel. Note that when producing high-octane number gasoline, a bit of benzene is expected to be produced. So, the presence of benzene in the total reformate has to be handled. I remind you that the benzene content in gasoline is limited to 1% in volume. Each refinery has its own technique to make sure they do not go over this specification. But why do we find benzene in the reformate? Simply because benzene is naturally found in the crude, but there are also benzene precursors. These benzene precursors are the molecules that will unavoidably become benzene in the reformer, even under soft operating conditions. Among these precursors, we meet methylcyclopentane, benzene itself, and cyclohexane. In their natural state, in the crude, the following precursor contents can be found. Between 0.4 and 2% in volume of benzene, with an average value of about 1%. For methylcyclopentane, this is between 1.5 and 5%, with an average value of about 3%. For cyclohexane, the value is between 1 and 5%, with an average value of about 3%. So, the total precursor content will be between 3 and 10% in volume, with an average value of about 7%. If the benzene and its precursors are left in the heavy naphtha, there is a risk of producing a total reformate with between 3 and 10% volume of benzene and an average value of about 7%. These concentrations are very difficult to manage if the specification of 1% volume is to be achieved in the finished gasoline product. So, what can we do about it? Part of the solution consists in doing what we said in the first video. That is to put a certain quantity of the benzene and benzene precursors into the light naphtha. If, for example, the objective is to recover 80% of the benzene and benzene precursors in the light naphtha, we can aim at a benzene content in the total reformate of 0.6 to 2% volume with an average value of 1.4% volume. But this is still too much to comply with the specification of 1% volume benzene in the total gasoline. Another part of the solution consists in installing a column downstream the debutonizer. At the top of the tower, we withdraw a light cut from which we will extract the C5 and C6+, which are lighter than benzene and which we will call light reformate. Then the medium weight reformate, where the benzene will be concentrated, and lastly the heavy reformate. In the heavy reformate, we will target a content of less than 1% volume benzene. The benzene-rich cut is usually sent to a petrochemical site. However, some refineries have no means of exporting their benzene-rich cut to a petrochemical plant and may handle the problem differently, by hydrotreating the benzene, for example. And so we reach our conclusion. One thing to note is that every refinery has at least one reforming unit, either semi-regenerative or continuous regenerative. This unit is vital in order to produce high-octane number gasoline, but also to produce the hydrogen required for the refinery to run correctly. These are dangerous units as the fluids are under pressure at high temperatures and there is hydrogen present. They also convey products with a high benzene content. The units are highly technical as they use rotating equipment, chemical reactions, and also fractionation processes. For the semi-regenerative reformers, the catalyst has to be regenerated at regular intervals, and catalyst regeneration is a delicate operation. These units change over time. Advantage can be taken of the fact that they naturally produce benzene in order to recover this cut. in which case we can aim at benzene contents in the order of 40%. The way the unit runs can also be optimized in terms of catalytic activity and stability by optimizing the operating parameters. I hope that these videos will have enabled you to discover the universe of catalytic reforming. Thank you very much for your attention. See you very soon. Bye bye.